Marcus is the star of his high school's basketball team. Opposing teams foul him often, but he makes his free throws 88% of the time. If Marcus takes 6 free throws in one game, what is the probability that he makes 5 of the 6 attempts? You may assume the attempts are independent of each other. Okay, so when I see this problem, I see that it asks me for probability. And it's important that when you see a probability question, you think about what technique is appropriate to solve it. This is one of the hardest things to do when you have a bunch of problems on a test that are, of mixed type, and they all say, what's the probability, or find the probability, or calculate the probability. It becomes very difficult to decipher which technique would work best or appropriately to solve the problem. What I suggest is if you have a situation where more than one activity is occurring, or more than one selection, or more than one trial of some experiment, then you should start to think about the possibility that it involves the multiplication rule or perhaps binomial probability. Now, a shortcut to checking, because you could look down both paths and decide which one is most appropriate, but the easy way to make that decision quicker is to say, hey, is every trial or selection turning out the exact same way? In other words, are they talking about him making 6 shots and he makes all of them? So in other words, he makes a point for every shot? Or is he saying that sometimes he makes a point and sometimes he doesn't out of the 6 attempts, right? So if all 6 attempts are going to turn out the same way, probably the multiplication rule is the best way to tackle the problem. However, if some subset, for example, if only 5 of the 6 attempts are going to turn out as successful, then I'm going to lean towards the fact that it might be binomial probability. And if that's the case, then I just have to run through the checklist in my head and see, does it meet the criteria for binomial probability? Well, let's see. First thing, are we counting the number of successes here? I think you could make a random variable that does that, right? You could let x be equal to the number of attempts he makes, right? And in fact, in this case, it would be that x is equal to 5, right? Do we have a fixed number of trials? I think we do. He's making exactly 6 attempts, so n would be equal to 6 in that case. What's the probability he succeeds? Does it remain constant from trial to trial? I think so. The probability seems to be 0.88. Do we have 2 possible outcomes only? Yeah, he either makes the shot or he doesn't, right? It either goes in or it doesn't. So only 2 possible outcomes. We could call the ball going into the net a success, right? And then finally, we have to ask if the attempts are independent of each other. And luckily, they tell us they are. So even though you might be doubtful of that, you might say, well, maybe he gets fatigued, or maybe making one would influence his likelihood of making another one, or missing one would influence it, right? So, but we will assume that that's not the case, and so the trials are independent of each other. And they probably are, at least approximately. So I think we're good. Of course, if P is 88%, then Q, which is the probability of failure, is just 1 minus 0.88, and that would be just 12% or 0.12 as a decimal. Okay, so there are the things we need. I think binomial probability fits because it meets the checklist or criteria for a binomial experiment. So we can then solve the problem by saying, hey, we're looking for the probability that the number of successes x is equal to 5. Then the formula says I should do a combination using n up front, then choose x, or in other words, out of 6 shots, 5 should go in, right? Then we need the probability of success, which in this case is 0.88, and we need to raise that to the x power, so we need to raise that to the 5th power. And then the probability that we miss, or the failure probability, raised to the leftover amount of trials. Well, if 5 of them are successful, then 1 out of 6 is unsuccessful. All right, and that formula should solve the problem for us. We just need to plug it into our calculator at this point. All right, so 6 choose 5 is the same as 6 choose 1, so it should just be 6, but let's type it in anyways. So we'll hit 6 math, go over to probability, take NCR, and my calculator here on the screen. You might have a different way to do that, but either way, 6 choose 5, there it is, times 0.88. We're going to raise that to the 5th power, and then times 0.12. We're going to raise that to just the 1 power. You could, of course, skip the raising it to a 1 power. You don't need to do that. Anything to a 1 power is just itself. So we hit enter and we get 0.3799, or if you want to round that off to 3 decimal places, it's 0.380. So 0.380, and that's the approximate probability that he makes 5 out of his 6 attempts. So about a 38% chance.